Welcome to the part 6 of the MSP432 MCU's training series. In this section, we will cover the analog peripherals, including the ADC14, the comparator E, and the reference module. Starting with the ADC14, it is a 1 mega sample 14-bit ADC that provides high performance, high resolution while maintaining ultra low power consumption. In terms of accuracy, the ADC14 achieves extremely low INL and DNL errors while maintaining extremely high ENOP at more than 13 bits. There are 32 input channels which can be used in either single-ended or differential input mode. The ADC14 also includes 2 Windows comparators. There are 2 separate internal channels that can be used to monitor the supply voltage or AVCC, as well as an internal temperature sensor. As mentioned earlier, while providing a high performance, high resolution ADC, this module also obtains extremely low power consumption, with single-ended mode consuming 210 microamps at 1.8 volts at 1 mega sample, while the differential mode consumes only 260 microamps at 1.8 volts at 1 mega sample per second. The ADC14 is the next revolution of the ADC modules in MSP families. Comparing to the ADC12, which is a 12-bit resolution ADC popular on several MSP432 devices, there are many new features that were introduced into the ADC14. So first off, let's take a look at Windows comparator. ADC14 introduces a 14-bit Windows comparator, and this feature is extremely useful for particular applications that need to monitor an analog signal to check when it falls within or outside a certain range. Traditionally, you would have to constantly monitor the signal, perform the sample and conversion, and then compare in software to see if it falls within the range or outside the range. Using the window comparator, you can configure the input threshold levels, the high and the low thresholds, and the ADC14 will continuously convert the result and internally compare the sample result against the thresholds, and it will trigger the interrupts depending on whether it falls below, between, or higher than the window. So this is very useful to keep the device stay low power, since no CPU activity is required until the analog signal falls into the range that is of interest. So in this example below, we have an analog signal that is being monitored, and after we have programmed the high and the low threshold of the window comparator, depending on whether you want to enable below or between or above interrupt, you can set the flag and trigger the CPU to wake up when the signal falls within the right range. So as you can see, at the moment the signal will set the ADC in between flag. As the signal rises above the high threshold, it could set the high flag, but again the in-between flag, and then the low flag. The next enhancement that was introduced to ADC14 is differential measurement. So this feature can be quite handy if you want to monitor 2 signals and measure the difference between the 2 signals. Traditionally, again, CPU is required to invoke the ADC to make the 2 measurements and use CPU to compute the difference and determine whether that is of interest. With the differential measurement feature, you can configure the ADC14 to automatically measure 2 channels, measure a difference, and store that difference directly into the ADC memory register. Next, we also have another feature that is new to ADC14, that is internal channel mapping. So traditionally on ADC12 modules, there are some dedicated external as well as some dedicated internal channels. Some of the internal channels are temperature sensor as well as a VCC monitor channel. So sometimes for certain applications that require absolutely as many input channels as possible, it can be inconvenient that some channels are fixed. With this in mind, the ADC14 introduces the channel mapping capability that gives you the flexibility to choose whether or not to use an external or internal channel. That way, if you want to use an internal temperature sensor, you can, or if you have a better source of higher resolution temperature sensor externally, you can also choose to use the same channel but with an external input. There are some other enhancements that were also introduced into ADC14. For example, now we have up to 32 input channels. It is a big increase compared to some ADC12 implementations with only 16 channels. The clock is also enhanced to accept more sources. Since the ADC14 operates at up to 1 mega sample per second, it requires a much higher clock. The primary clock source for ADC14 is MODOS, which can run up to 25 MHz. However, when ADC14 runs at a lower sample rate, such as at 200 kilo sample per second, it does not require a higher clock source. A smaller, slower clock source, such as sys-auxx running at 5 MHz, can be used. This allows the ADC14 to consume less power and be more efficient. The next analog module that MSP432 MCU introduces is a comparator E. It is an ultra-low power comparator that is, it's been introduced in previous MSP430 families. The comparator E is created for ultra-low power consumption. It can also be interrupt-driven for low power operating modes. It has up to 15 external input channels, and it also uses the reference module to create the reference voltage. The output of the comparator E is also internally connected to the timer A capture input. This way you can create an event capture or use it for capacitive touch implementations. There are two instances of comparator E provided in the MSP432 P4XX family. The next analog module that is introduced in the MSP432 family is the reference module. The reference module is extremely flexible with different power as well as operating modes that the reference can be used to generate the voltage output for various analog modules. The different voltages are 1.2 volts, 1.45, and 2.5 volts. The reference can also be brought out to an external pin that can be used to drive external peripherals. As mentioned, the reference can be programmed in two different power modes: in static mode for high precision, as well as sample mode for low power operations. If the reference is only required for ADC conversion, it can be put in burst mode where the reference output is only available during the conversions. However, if the reference output is also used to drive an external component, the reference can be put on the continuous mode to have it continuously on. And depending on the power mode, there are two buffers that can be used to throttle the power consumption. In burst mode, where the reference output is only needed only at certain times, a smaller buffer can be used. However, for driving an external component, a larger buffer is used. So knowing what your system requires can help you throttle the power consumption for the entire device. Similar to other MSP devices, the reference module is also used to drive the power for the temperature sensor. It is the internal temperature sensor channel that the ADC can use to measure the temperature of the device. With this, we have concluded the analog peripherals chapter of the MSP432 MCU training. We have covered the 1 megasample 14-bit ADC module, the comparator E, as well as the highly flexible reference module available on MSP432. Thanks for watching.